Let us understand what is the meaning of the word maximal. A set is maximal if it is not contained within a larger set, which is not a subset. For example, I have taken taxa ABC over here and taxa DE over here. I can say ABC is a maximal set if I am not considering ED at all. Or if I take A from here and ED from another section, then we can say AED is another maximal set, depends how we are defining. And as per my requirement, the same species, what is that here? A can stay in two maximal sets. Now, we will see a unitary association. A unitary association is a maximal set in the way it is defined here of mutually compatible species. Compatible species means which actually coexisted or virtually coexisted. So, in this example, ACB is a unitary association. Why it is a unitary association? They are mutually compatible. Why it is mutually compatible? Because I can find a common time range when they coexisted. They coexisted here. So, they are in this case actually compatible. It is not virtually compatible, it is actually compatible. That is why once I take ABC together, I can call them as the unitary association. Can I give an example of species which define a maximal but not a unitary association? Example is P and Q. These are the two taxa. Suppose I consider P and Q together making a set, then it is a maximal set. At the same time, they are not compatible. P and Q are not compatible. So, this is not a unitary association. This is not a unitary association. Now, an ordered sequence of unitary association is a proof referential. That means, taking this case of ABC, I can write the same set in so many ways: ABC, CBA, ACB, etc. Now, if I define an ordered sequence with some purpose, then that one will be called a proof referential. Out of these three, suppose for some purpose we define that this is the ordered sequence CBA, then this will be called a proof referential. Now, we define unitary association from several sections which may be nearby places or which can be far away places, and if I find that what I am defining is compatible or valid for a large areal extent, large geographical extent, we call that association also as reproducible. Large geographic area, how large, that is not defined within the definition, but it is sufficiently large so that we have high confidence that the unitary association is reproducible, it is a real one, sufficiently large. Now, using the reproducible U dot A dot is basically the unitary association. Ordered sequence of reproducible unitary association defines a biochronological scale. These definitions are the building blocks of further studies of biostratigraphy. Now, let us look at how from the vertical sections P1, P2 and P3, if we get fossils like this taxa 1, 2 and 3, 3 over here, note 3 is in the same level and here is 2, so 2 is in the same level. How do we present? There are several ways of doing. One very easy way is that write down the vertical sections P1, P2, P3 as vertical columns. They were the vertical columns, and here also in the matrix we keep them as the vertical columns. Now, we take the taxa 1, 2 and 3 for different columns. 1 will mean it is present, 0 will mean it is absent. So, 1 is present in P1, so it is 1. Similarly, 0, 0, 1, 0, 1 and 1, 1, 0 are filled up. So, it may or may not be a square matrix. Here eventually there are 3 taxa and there are 3 vertical successions. So, it has become a square matrix, but suppose we are dealing with P1, P2, P3 up to Pn, and we are dealing the number of species as A1, A2 up to Am. If M not equal to n, then it will not become a square matrix. The other way to present is that taxon 1 is present in P1, taxon 2 is present in P1, P3, and taxon 3 is present in only P2 and P1. This way we can present. So, what we are seeing, this is of course one kind of presentation, matrix is a second kind of presentation, and this way of writing is the another way of presentation. Note here, within the matrix we have got two kinds of 1. This 1 means present of same meaning here, here and here, and here this one means the taxon. So, this one and that one, they are not having the same meaning. Consider a barren log, that means no fossils, no taxa. So, which means we do not have anything. So, how the matrix representation will be? The matrix will become a null matrix. Say this is P1 and I want to present it a null matrix. Suppose all the taxa are present in all the logs. An example, P1 where x, y and z are present, P2 x, y and z are present. Then how I will present it? I will write in this way, P1, P2, x, y and z, and all the elements will be 1. Very easy to follow. Now, let us take an example of 4 vertical columns. Here is the P1, here is P2, here is P3 and here is P4. Earlier in many of my drawings that was a single column where we were doing. Now, we are basically compiling the information from the 4 columns and it is not difficult to understand. Let us look at the taxa. We have got the taxa 1, 2, 3, 4, 5, 6, 7 and 8. Take the case of P1 first. 1 and 2 were coexisting, 1 did not continue vertically up, but 2 continues from here, where 2 ends, 3 was found, 4 was found, and then 5, 6, 7 is not there in P1 and then straightway 8 is found. Now, in P2 section we are finding 1 and 2 occurring together just like what was found in P1, then 2 did not continue in section 2 for some reason, but 3 and 4 are together just like what I found in P1. 5 is also found here, 5 started in fact before 4 and see here 5 was absent. So, in this way first have a clear look at these 4 vertical sections, and in the way I am thinking, you think also for P3 and P4, it is important, otherwise jumping here will be difficult. So, pause the video, get it done, make it clear. I hope you pause the video. Now, let us come back here. Now, we are compiling basically the 4 successions. So, this symbol and 8, that means whatever lies below 8. Now, here I am writing 1, 2, 3, 4, 5, 6, 7 is not there. Why 7 is not there? Because I can see 7 and 8 were together in 2 sections. That is why 7 is excluded. And if I give this symbol and 1, that means whatever lies above 1. We have seen examples where 1 and 2 for some time were together. Therefore, in the compiled one, 2 is excluded. So, this symbol and 8 is given, that means above 8, nothing is available in my succession. So, it is a null set and this will be same as this symbol and 1. Now, I can write U 4, 8 is an arc. Why it is so? Because I can see clearly 4 lies below 8 in all the cases. Here 4 is not there. In P3 4 is not there. Here 4 is not there, and here 4 is lying below 8. So, 4 is below, 8 is above. So, U 4, 8 is an arc. And interestingly, u1 comma 2 is not an arc, that has to be understood. Here 2 is continuing above 1, true, but for some time they were together. Since that is so, we will not consider u1 comma 2 as an arc. Just following the definition and expanding the concept in biostratigraphy. Now, from here we are going to draw the coexistence graph, which is a non-oriented graph. That means there will be no arrows involved. It is not a directed graph or not a digraph. So, 1 and 2 coexisted. Where do I see? I can see here and here. Basically, I am compiling from all the 4 vertical sections. I am not taking one section and drawing. Now, 2 and 3 coexisted. They were joining together. Where is that? Here I can see for some time 2 and 3 coexisted. So, I have joined. While doing that, I understand here 2 and 3 are missing. Nevertheless, I have joined because I am compiling. I repeat, I am compiling the 4 sections. 3 and 4 coexisted. Where is that? Here we can see 3 and 4 coexisted. Here also we can see 3 and 4 coexisted. So, 3 and 4 are joined. 4 and 5 also coexisted. Where is that? I can see here 4 and 5 coexisted, and where else? Nowhere else. So, 4 and 5. Then 5 and 6 also coexisted. Where is that? I can see 5 and 6 coexisted over here. So, it is drawn. 6 and 7 coexisted. 6 and 7 coexisted here, and 7 and 8 coexisted. 7 and 8 coexisted. Where is that? This is the one where 7 and 8 coexisted. In addition, 3 and 5 coexisted. Where is that? Here 3 and 5 coexisted. So, this edge is drawn, and 2 and 4 also coexisted. Where is that? Here it is getting a bit clumsy, but nevertheless I hope it is visible. This is 2 and this is 4, and they coexisted. So, that is drawn. 2 and 7 never coexist. They were never in the same level. Check all P1, P2, P3, 4, they did not coexist. Similarly, 1 and 8 did not coexist. They were not found in the same level, and 6 and 2 never coexist. 1 and 6 never coexist. 1 and 7 never coexisted. 2 and 7 never coexisted. 1 and 8 never coexisted. If we look at all the 4, 6 and 2 similarly, 1 and 6 and 1 and 7. So, they are not joined by edges. So, here not joined by edges do not mean that they cannot be coeval. Let us try to understand it. 2 and 7 may indicate one is at the top, another is at the bottom. It can also indicate that if we compile from several sections, 2 of these nodes or 2 of these taxa were together at some time, but we do not see them in the section. Let us give an example. I am taking 2 vertical sections P1 and P2, where the distribution of taxa 1 and 2 are shown in vertical succession, and in P2 2 and 3 are shown. Suppose I want to represent the coexistence graph, how it should look like. I will put 3 points 1, 2 and 3, and we find that 1 and 2 coexisted for some time. Where is that coexistence? It is over here. And I find 2 and 3 coexisted for some time in P2. So, I will join 2 and 3 by a line. Now, if I put the absolute time scale over here, we find that indeed there is a time span from Tm to Tn where 1 and 3 existed on the earth, but not found in any section. Let me write down. From Tm to Tn time, 1, 2, 3 existed on the earth coevally, but no single section Pi is found where 1 and 3 coexisted. Since I do not see, therefore, I will not join 1 and 3. So, from the coexistence graph, what we can say that the vertices that are not joined, or the taxa represented by vertices which are not joined, might have existed in the past on the earth at the same time. So, I can write here 1 and 3, even if 1, 3 are not connected by edge. And now imagine some section is found P3 where we find that 1 and 3 coexisted for some time. Say this is the one. Once it is found, then only I can join 1 and 3. This is important. At the same time, suppose the vertices are not joined, just like this diagram, it also does not guarantee that 1 and 3 always coexisted for some time on the earth. Take an example. So, here in section 1, 1 and 2 coexisted given by this edge, and here 2 and 3 also coexisted given by the edge, but you can see 3 and 1 never coexisted. So, from this graph, two possibilities are there. You cannot pinpoint exactly, this has to be clearly understood. Now, we come back to our starting 4 vertical successions P1, P2, P4 and P3. We are now going to make a matrix presentation of all these 4 vertical successions taken together. We are not taking a single one. We are dealing with 8 taxa. So, we have got 8 columns. Here numbers indicate the taxa, and naturally we will have 8 rows. Now, what I will do? I will use 2 numbers, 1 if they coexisted and 0 if they did not coexist. So, in that sense 1 coexisted with itself. So, it is 1. 1 and 2 coexisted for sure in our P1. So, it is 1. 1 and 3 never coexisted. You look at P1, P2, P3, P4, 1 and 3 never coexisted in the same horizon. So, it is 0. Now, you take let us say 6 and check by your own. After you have understood it, now you write by your own, that is very important. And I ask you a question, is this a symmetric matrix or an anti-symmetric matrix? Take your time and find out the answer, must be done. All these small steps are very important. So, the graph that I have drawn here is redrawn in this way. Same graph has been drawn. The edge length does not matter. The geometry that is shown by the graph, the diagram does not matter, only what matters is the connection that is being shown. It shows only the coexistence and it does not comment on which one lies above or below which one, that is another point. From this diagram, you cannot comment whether 8 lies below 1 or above 1. You cannot comment whether 6 lies above 2 or below 2, both possibilities are there. So, there are many uncertainties, and this graph, this coexistence graph does not 100% reveal those compiled information from those 4 vertical successions. Now, suppose I find out the complementary of the G matrix, this G matrix or the G graph is given by GC. So, what does that mean? Where there were edges, that will be gone. You can see now there is no edge between 1 and 2, and where there were no edges like 2 and 6, there were no edges, that has been joined by a straight line. Now, my question to you is, what kind of geological knowledge required to create GC? Then I leave this question to you. This means possibly a completely shuffling of the paleontological knowledge. What we were thinking to belong to the same horizon do not belong, and we find out what was either above or below. Let us say 2 and 6, one was above and another was below. Now, they are in the same level. Once you look at this one and that one, in the same slide I have kept again the same 4 vertical successions, so that you can compare easily. And we need to emphasize, this graph does not mean, let us say 2 and 3 I take and they are connected, that they appeared and disappeared from the earth at the same time. No, does not guarantee. This is possible, that is possible, this is possible, and also this is possible. And just to make it very clear, you can see 1 and 8 never occurred in the same horizon in all these 4 examples. So, for that reason 1 and 8 were not connected. This was not connected in the diagram. Here you can see they are not connected, they are disjoint. Okay, now we start with the same 4 vertical sequences P4, P3, P1 and P2 and move forward. We are now going to understand superposition graph. We will use the same vertices 1, 2, 3, 4, 5, 6, 7, 8 as the 8 taxa, but a new kind of graph will be created. So, the concept of creating the edge will be different from what we have done with the coexistence graph. In the superposition graph, first of all it is going to be a directed graph, that means we are going to have directions. Here let us try to understand by taking the example of 1 and 8. Since 1 is below 8, so this arrow is given. So, this is one way of putting the arrow. Then we can see here 2, look at its complete range, it is certainly below 8. So, 2 is below and from there arrow goes to 8. 3 lies below 8. Where do we find in this section? 3 is lying below 8. So, therefore, the arrow goes in this way. So, it is talking only about the superposition, what is at the top, what is at the bottom. In the case of coexistence matrix, we were talking what were in the same level. Here we are telling what is at the bottom and what is at the top. Now, let us take 4 and 6. We will find some section where 4 is at the bottom, 6 is at the top. Where is that? Here we can see 4 is at the bottom, 6 is at the top. So, this is being shown. So, in this way all the arrows are made. It is talking only about what is at the top, what is at the bottom. If you compare this graph with the coexistence graph, here you can see the coexistence graph where 1 and 2 were joined, meaning that at some vertical section we found taxon 1 and taxon 2 to occur in the same level. Now, that issue is gone over there. We are not putting any edge connecting 1 and 2. Now, we are going to look at the third variety, that is called the biostratigraphy graph G star, a combination of G and GS. First, look at this superposition graph GS and bring all these arrows over here as it is, and then also recollect this graph lines which are joining and bring that over here. For example, here 1 and 2 are connected, 2 and 3 are connected, 3 and 4 are connected. Here we find 1 and 2 are connected, 2 and 3 are connected, 3 and 4 are connected. Similarly, 4 to 5, 5 to 6, 6 to 7, 7 to 8 and then 3 to 5 are connected and 2 and 4 are connected. Note that what I have drawn right now with black line, they do not have arrows. So, we are dealing with basically semi-directed graph. What does that mean? In this graph there are some arrows and there are some edges without any arrows. So, it is a mixed kind of graph. So, what is the information that is provided here? Coexistence given by only lines and no arrows, and the up and down relation, what is at the top and what is at the bottom, given by the directed lines or the directed edges. Two things are given. Now, from here we want to formulate a matrix and we have to be alert here. We are going to add 1 as the matrix element if xi is in the same level, very important, same level or in the lower level than xj. What does that mean? 1 and 2 are in the same level, that is why they are joined. So, we can see 1 and 2, here I have given 1, and if I take 1 and 6, here is an arrow, 1 in the lower level than 6. So, 1 towards 6, this will be plus 1. So, you can see plus 1 is having two meaning and it is non-unique. 1 to 2 it is 1, that means they are connected, they are in the same level, but 1 to 6 is 1, here it means it is at the bottom. So, this matrix does not give complete information about the graph, but that is how we are working. And if this is not the case, we put 0. That means we said 1 lies below 6. So, what happens if 6 lies above 1? So, this 0 has come, no minus 1 has come. It has to be very clearly understood. Let us take other number here 0 and 1, try to understand. The taxon 8 lies above 6. So, we have put here a 0, but if I take 6, taxon 6 lies below 8. So, I have given here a 1. If you observe carefully, it is neither a symmetric matrix nor an antisymmetric matrix, at least in this particular case. In one of the sections we have seen 5 and 3 occur in the same level. Therefore, 5 and 3 occur in the same level. So, it is 1. Similarly, 3 and 5 occur in the same level. So, it is 1. So, this column 1 to 8 taxa we are calling from, and these row with taxa 1 to 8 we are calling to. Always we are saying from here to there. So, Vi we are starting from some vertex, we are going here and to Vm, and in this way we are comparing. If from Vi to Vm we are finding the element is 0, then Vm to Vi will be either plus 1 or 0. How to explain it? From V5 or 5th towards V1 from and to, if it is 0, one chance is that then from V1 1 to 5 here is 1. So, what has happened? If it is 0, here it can be 1. Now, take another example when Vi to Vm is 0, but Vm to Vi is equal to also 0. For example, from 7 to 2 is 0 and from 2 to 7 is also 0. So, that is a possibility. Now, conversely, Vi to Vm is 1, Vm to Vi will either be 0 or equal to 1. So, both possibilities are there. Let us understand this line. From Vi to Vm is 1. For example, from 1 to 2 is 1. So, from 2 to 1 is also 1. So, from Vi to Vm is 1, then Vm to Vi can be 1. This is established. Now, let us take a case where Vi to Vm is 1, but Vm to Vi will be 0. Let us try to see. Let us take this from 6 to 8. From 6 to 8 is 1, but from 8 to 6 is equal to 0. So, this is also being shown. So, you cannot predict. If I give you part of the matrix and ask you to fill up the other part, it will not be possible. Two possibilities are there. So, this presentation does not give complete information of the vertical sequences. Now, the last matrix that we were dealing, let us call it G star. We can do a G star X operation. What is that? We can remove the coexistence edges. These edges are out and that is being shown. You can see there is no edge over here, and also inside the 2-4 connection is gone, and create the new edges. Earlier 2 and 7 were not connected. You can see 2 and 7 were not connected. So, now a new connection is established. Earlier 7 and 3 were not connected. Now, a new connection is established. Earlier 7 and 4 were not connected. Now, 7 and 4 are also established. So, this operation from G star we can write G star X. A new operation is done. Matrix wise M star will become M star X. When we said that 2 and 7 are not connected, that means as per the diagram we do not have direct evidence of relationship between 2 and 7, similarly between 7 and 3 and between 7 and 4. This is the meaning of the existing edges. Now, over this transformation my question to you will be, what can be the geological significance? We will look at some other definitions. If taxon X1 was deposited in sedimentary bed B, then we can say that B was deposited in existence interval. This is the term stated as the Jx1. What would be the diagram? This is a complete succession, and here is the bed B and here x1 is found, then we say that B sediment was deposited within the existence interval of x1 represented by jx1. Now, if B contains more than one taxon, so we have got taxa x1, x2, maybe more, then B was deposited in the combined interval of x1 and x2 represented by jx1, x2. Let us try to explain it. With the taxa A, B and C, J, A, B, C I can write, and this is the common zone, this is the meaning of J, A, B, C. For n taxa, of course, we can write J, x1, x2 up to xn. Now, let us look at the J, A, B, C in this case. A is drawn, B is present, C is present and D is present. I have taken only 3 of them, A, B and C, and we can see that the boundary is being drawn. This is the boundary. So, now we will take J, B, C, D, J, B, C and D. So, here what is the common? This is the common place. Now, in this case J, A, B, C and J, B, C, D have common element B and C in both, and they have a common physical boundary. This boundary means physical boundary. Where is that common boundary? That common boundary is here. This is the common boundary, the lower boundary has superposed. So, from here we can make some simple statement, but having common elements A, B, C, D do not guarantee common boundaries. I am asking you to make a sketch. And second statement, having common boundary does not guarantee common elements. Make such a sketch. You can pause the video for a while, then you can run. I am going to make the sketches here and you can cross check. So, I am starting. This is taxon A, taxon B, taxon C and taxon D, and I can write here J A comma B is given by this portion, and I can write J B comma C is given by, and you can clearly see that J A B and J B C do not have a common boundary. They even do not share a common region, even though the element B is common. This is a common sense thing, just putting some symbol and trying to explain. Now, the second one, having common boundary does not guarantee common elements. Let us try to understand it. So, here I have given the example of case 2, A and B are 2 taxa and JAB is shown here, and C and D are the other 2 taxa. JC comma D is shown over there, and A comma B and C comma D do not have any common element, but at the same time one of the boundaries of JA comma B and JC comma D is the same, which is this boundary. So, this common boundary does not guarantee that between J this one and J that one common elements will be found. Again, this is a very common sense thing, but just putting some symbols, this has also been explained.